y double dashed plus 8y dashed plus 16y equals 3 cosine 2x. So let's do the sub-problem then. The first one we need to solve for is yh. Let's do that one first. So here we can write y double dashed plus 8y dashed plus 16y is equal to 0. Auxiliary equation, lambda squared plus 8 lambda plus 16 equals 0. Now, is that 4 fours? Looks like it, doesn't it? So here we've got lambda, 4 and 4. So it's a repeated root, plus 4, yeah? So that tells us that lambda equals minus 4. It's case 2. Case 2 gives then? Gives y equals a e to the lambda minus 4x plus bx e to the lambda minus 4x. There we are. So that's the that solution then for that sub-problem. Now let's turn our attention to yp, the particular integral solution. So we've got 3 cos 2x. Let's look at our table. 3 cos 2x, we must try a sine 2x plus b cos 2x. Let's try that then. So try y equals a sine 2x plus b cosine 2x. And I'm going to copy this equation because I may want to copy and paste it now and again. Let's just take that one. I'm just going to copy it. Save a bit of time later on. Okay, so let's go down then. And we need, that's y itself. So let's differentiate then. So differentiating y dashed, what do we get? Sine goes to cos and the 2 comes out. So it's 2a cosine 2x plus, no, it's a minus, isn't it? Because cos goes to minus sine and the 2 comes out again. Minus 2b sine 2x, there's y dashed. Now differentiate again for y double dashed. Again, when you differentiate cos of something, 2x, the 2 comes out and you get 4 with a minus 4a. Cos goes to sine of something, 2x. And then the sine goes to cos, and then the 2 comes out when the something's differentiated to be with the other 2. So it's minus 4b cosine 2x. There we are. So now, that's what we've got. So we want to sub it in, don't we? So let's just remind ourselves what we were dealing with. Oh, it doesn't come up. So let's go back up then. Y dashed plus 8y, y double dashed, 1 of these, 8 of these, 16 of these equals 3 of those. Okay? So substitution then. So remember what we said? It was 1, 8, 16 equals, how many? 3. So I'm just putting the numbers to remember. So 1 of these. So substitution then gives 1 of these. Sine 2x minus 4b cos 2x plus 8 of these and then plus 16, wasn't it, of these. There we go. And that was equal to then 3, and was it sine or cos? I think it was cos. Cos 2x, yeah, there we are. So 3 cosine 2x. So we've got 6 terms on the left if when we expand the brackets here. Use the 2 lines and see the individual or the constituent parts. There's 6 of them. So let's equate sines first, shall we? So let's equate the sines on both sides. Because sines and cosines are linearly independent. So the sines, number of sines on this side of the equation will equal the number of sines on this side. And the same in regard to the cosines. The cosines on this side will equal the number of cosines on that side. So first of all, the sines then, that will come from this term. this term and this term. So let's do that. Without further ado, minus 4a. Lots of sine 2x there. And then the other side, 8 times minus 2 is minus 16, not b. And then the other one would be plus 16a. And how many signs on this side? There's none. So we've got minus 4a plus 16a. So that's 12a. And we're going to move the 16b over, so it becomes plus 16b. So a will equal to, then divide by 12 both sides. 16 over 12 is 4 over 3, isn't it? When we divide out the common 4. So there's the first piece of information. Now that was equating sines, so now let's equate cosines. And see what we get there. So the other three, minus 4b times 1 is minus 4b. Then the other cosine is here, 16a plus, and then the other cosine plus 16b. And how many cosines on the other side? 3. Cosine 2x is, yeah? So we get that. So let's turn our attention to this problem now. So 16a, and then minus 4b plus 16b is plus 12b, isn't it? Plus 12b is equal to 3. So sub 1 in 2 then. Sub 1 into 2 gives, so 16a, and a is equal to 4/3 b. So put that in. Plus 12b, yeah, which is here. That's the 16a, and a was 4/3 b. Plus 12b equals 3. So let's work out what b is then. 64/3. 16 fours are 64. This can be written as 36/3 is equal to 3. So that's 64 and 36, that's 100/3, isn't it? Over 3 lots of b is equal to 3. So that tells us then that capital B equals 9 over 100. And then we can work out A. A is 4/3 b. So A equals 4/3 of b, which is 9 over 100. So the 3's will cancel, and there'll be a 3 times 4 is 12 over 100. So final solution then, consequently, y is equal to yh plus y is equal to yh plus yp. Now I got to try and remember, but I'll go back up, sorry, just to get them. So let's go back up and get them. So that was yp there. Here's yh, a e to the minus 4x plus b e to the minus 4x. So I wonder if I can just copy that a moment. Edit, copy. Come down to the bottom and see if it will paste in here. Edit, paste. No, that doesn't work. So let's just go back to the pen then. And go back up and read out from memory what it is. A e to the minus 4x plus b x e to the minus 4x. So capital A e to the minus 4x plus bx e to the minus 4x. And then we had our particular solution. And our values for that, for the a and b in that case, which is a different a and b, should have been lowercase, shouldn't it? Here, when we tried this should be lowercase a sine 2x plus b cos 2x. So that lowercase a and b, a sine 2x, 4/3, sine 2x, plus b, which is 900. B is 900, cosine 2x, and a was equal to not what I've written. A was equal to 1200. There we go. There is an error in terms of form here, because these should have been lowercase a's and b, shouldn't they? So that they would be distinguished from the other sub-problem that we did. So there's no confusion. So there's a general solution then.